Good afternoon. We're going to wrap up this conference with, at least for my part, talking about water heaters. We're going to talk about the TREC Standard of Practice, and we're going to mention InterNACHI, but you'll see there's just not much there pertaining, well, there's not anything there specific to water heaters. I'm going to pause every now and then for questions, and you will enter your questions in your chat box. Brenda will pass those on to me. That way we are verbally, we'll just pause for that. But I do encourage the questions. Course outline, we're going to talk about the reporting requirements. We're going to talk about location and access of the water heaters, physical inspection, and then we'll break down some specific requirements for electric and gas water heaters. And then I'll end by showing you some quick references and pick up any of the last minute questions that you might have. Reporting requirement. We're required to report the energy source. Best I could come up with, folks, was electric, gas, including liquid petroleum, and solar powered. There are some heat pump type water heaters now, but those are electric for all intents and purposes. And then we'll talk about capacity. Well, TREC is the only one that says we want to know about energy source, but both TREC and InterNACHI want to know about the capacity. Well, the inspector is not required to determine the efficiency or adequacy of the unit. And it sort of seems that capacity contributes to the adequacy of the unit. So we're going to talk about that here shortly. Efficiency. What affects efficiency is the fuel type and the cost of that fuel, and that is often the thing that will make people choose one or the other. But the energy code requirements have made the requirements for efficiency so much higher that I don't know that that makes too big a difference. Size, we're going to talk about size here in a second, and then the energy efficiency we'll talk about. Well, I just talked about that. So types of water heater. We have conventional storage. That's pretty much what we're used to and have been and see most of. We have the conventional storage water heaters where the water is heated, it stays in the tank until there's demand for it. It lets the hot water out and brings cold water in. Tankless or on-demand type water heaters. We're starting to see a lot of these. They heat the water as the water passes through the coils. It doesn't store it, so it only heats it as it is used. The heat pump, it transfers the heat rather than generates the heat. So just like an AC heat pump works, moving the heat, that's what happens with the water heater. Solar water heater, I've never seen one, but basically you have coils outside the house that pick up the water and move that through, and it's generally moved into a tank and circulated so it doesn't go, doesn't cool off in there. And tankless coil and indirect, it uses the home's heating system to heat the water. Well, that might work in this winter, but not down here along the Gulf Coast. We would just have maybe hot water one day a year. So let's talk about capacity. Now, we can go in there and generally in a house today, we'll see 40 and 50 gallons. And the 40 is often overkill for a lot of houses. But how do they come up with the capacity? Where there's a feature called the first hour rating. Now this is a newer label that's required. It is a newer calculation that's required. And you probably don't see any water heater 3 or 4 years with this first hour rating, but it's now required to be on the label. The first hour rating is the number of gallons of hot water that it can supply starting from a full tank. So you get up in the morning, all the water's been heated overnight, the tank is full of hot water. The minute you begin using it, you begin depleting the hot water, adding cold water, and tempering all the temperature inside there. So this depends on the tank capacity, the source of heat, type of energy, and the size of the burner or the element. So this label is now required for water heaters that matches within 1 or 2 gallons of your peak hour demand. So what you're to use is the one that most closely provides the water that you need in that first hour. So here's how that calculation is done. And here, over here on the label, you see capacity first hour rating. So it says 61 gallons. So this would be adequate. You notice on here, it doesn't say anything about the capacity, though. From the model, you can see that's a 50-gallon water heater. So that 50-gallon water heater will provide 61 gallons of hot water in the first hour, assuming that it hasn't been used for some period of time. So what you do is you calculate what your actual usage is. So you're going to take a shower, use about 10 gallons. You're going to shave, use about 2 gallons. I don't know how they use that much unless they just leave the water running. Hand washing, food prep, etc. So you would calculate all that. So you might take 2 showers in the morning. That'd be 20 gallons in 1 hour, etc. And you come down here and you get your calculation. And if you're within 1 or 2 gallons of 61 gallons, then you're in the right water heater. But remember, we are not required to report anything about capacity or efficiency. But if you're in a house that is obviously with an undersized or obviously with an oversized water heater, this is a good way to discuss with your client the demand on it, because I've run into a house that had a 50-gallon water heater with 1 bathroom, 1 kitchen sink, and 1 person lived there. So that was obviously overkill, and they're spending a lot of time and money heating water that will never be used. Well, why did they bother getting that? Well, they worked at Home Depot and they had an opportunity to get a surplus water heater. So they got that free water heater, and for as long as that water heater worked, they paid more money. They could have probably bought one for the right size and come out well. So for that 1 bathroom, 1 kitchen, 1 person, 30 gallons would have been adequate. But 50 gallons is what they've got. So you're not going to sit there and calculate all of that with your client. You're not required to. But what's a real quick way of doing it? Well, you can just figure it out this way. 1 to 2 families, or 1 to 2 family members, 2336. So you're going to get a 30-gallon water heater, more likely than not. 2 to 3, 40. 3 to 4, 40 to 50. You get more than that, then you can get an 80-gallon water heater, but you're not going to try and put that in a residence because you're not going to find a place that will fit. So when you get into that, you start breaking that out into multiple water heaters. Well, let's talk about it right now. So there's 2 different ways that you can install these. This, I just realized, got cut off at the top, but this is in parallel. So the cold water line right here, it has a cold water line and they're tied together in some manner. And then the hot is tied together. So the water fills up both tanks simultaneously, heats the water simultaneously, and the hot water comes out simultaneously. And that's what you have over here. So here's your T on the cold water lines. Here's your T on the hot water lines. So this is installed in parallel. So this would be how this household gets to the larger capacity, like this 50 to 80. So 2 40-gallon water heaters will take care of them. Well, in addition to the parallel, you have series. They've cut it off here again, but you see clearly cold water in, hot water to the cold water and out. So which is best? Well, I'll show you something here in a second, but let's think about this. If the right-hand tank fails, then all the water going into this smaller tank is cold. Well, that's no different than having a single tank. And it would be undersized if they calculated it and figured out they needed the two. But let's say that the left-hand system failed. And by failed, I don't mean leaked, I mean it stopped heating water. Then you're going to take hot water from the first tank and dump it into the second tank where it cools off, and you'll never be able to keep that cool. Sorry, hot. So you have parallel versus series. And just as an aside, you'll look back here and you see the bonding jumper. So they have used this bonding jumper from that side over to the other. We don't always see that. We rarely see it, but that's just an example of it. This is from the State Technical Bulletin. It says the installation of series water heaters is simpler. It's less expensive. It uses less parts, less connectors. It just goes from one to the other. Less couplings, less lines, less problems. But with everything being equal, if you put them in parallel, you're going to have better water performance. So we talked about water from two in series and the failure modes, but if you have two in parallel in the failure mode, there's still going to be two of them heating, and it's just that the water is going to come out from the two, mixing hot water with the cold water from the first tank, and it won't cool off to the extent that the second tank in a series will fail, but this will still not provide hot water. So there's no solution to multiple tanks other than both of them need to be functional and well functional. I have gone and seen different thermostat settings for the two. I don't know that that was due to some problem or perceived problem and the homeowner did it, or they just didn't understand. But when I'm inspecting a water heater, I am looking at the thermostats, and we'll talk about why I'm looking at the thermostats a little later. And then you have multiple water heaters where they're zoned. It says, code says, this is the plumbing code, says that the distance from the water heater to the fixture shall not exceed 50 feet. So you're going to have some cases where the distance from one side of the house to the other is more than 50 feet, so they end up with a water heater on each side. You often will see the water heater as close to the center of the house as possible, and then it might be 50 feet in any of the directions, and that's generally where we see the two water heaters together, whether they're parallel or series, in the center of the attic, center of the house, and then they go out all the way. But the distance alone is sometimes what requires separate water heaters. Shall not exceed 50 feet. Now here's an example. You'll notice that the two on the left are in series. We have the water in, water out, water in, water out, where this one is not connected to them at all. So you have two in series and one that's zoned. Obviously, this is a large house. I think this was 1,800 square feet. Okay, sarcasm. So you have three water heaters there. So what's the difference in a water heater and boiler? You have a lot of people, no offense to anybody from up north, but they'll call them a boiler. There is a difference between a water heater and a boiler. Pretty much everything we deal with is water heater. These, without going into a lot of detail, if it's above 120 gallons, it's going to be a boiler. If it operates more than 160 psi, it's going to be a boiler. Or if the, that's pressure, I'm sorry, 160 psi pressure and then 200 degrees temperature. This final one down here is probably the one that more likely than not in our systems and operations means that ours is a water heater. Those that we deal with in 30, 40, 50, and even 80 gallons are going to be water heaters as opposed to boilers. Now, if that was my wife showing me an injury. If it is a boiler, then many jurisdictions come in that say, okay, now we have to have special requirements. We have to have a national board inspector. We have to have a different kind of inspection before it can be turned on, fired up, or energized. And the local authorities are often going to have rules that will apply to them if it is a boiler. Don't have to deal with that pretty much. All right, standards of practice, InterNACHI. This is the entirety of the plumbing section for InterNACHI standards of practice. And you'll see that it doesn't say anything about water heaters specifically. It doesn't say much about plumbing. So we're going to spend all our time focusing here on the Texas Administrative Code. We're required to report inoperative, non-functional units. Well, how do you measure that? Doesn't heat water. That is the easiest, simplest way to say that it's not functional. And sometimes it's because the energy source, you can't energize it. You can't light the pilot. Electricity has a problem. There's no power to the appliance. So inoperative is not something we can always diagnose the cause of, but we can say it doesn't heat water. What about performance of the water heater? Remember, we're not required to talk about the efficiency, but a lot of times the performance is showing inefficiencies. So it doesn't produce hot water, it's not functional. But what if the water temperature doesn't reflect the thermostat setting? A lot of times we'll see an older water heater where they'll just crank up the thermostat setting. This is a picture I took. This is real case scenario. So I get 114 degrees water temperature at the kitchen sink, and it's set to very hot. And at very hot, I should expect temperatures of about 150 degrees. So this is a gas water heater, but we're not excluding electric water heaters. Again, real case. Notice that this thermostat setting is 150 degrees, and this thermostat setting is 125. And the supply temperature at the kitchen sink again is about 107 degrees. Now, this is not two separate water heaters. This is an upper element and this is a lower element. Not every water heater has two elements, but the majority of them are going to have two elements, and certainly those in the 40 to 50 gallon area are going to have two elements. There are 20 gallon units and 30 gallon units that might have one element. A lot of times you'll see those in a shop, detached garage, or some sort of pool house or something like that. But in both of these cases, I think I could say we have a performance problem, and it's based on providing hot water not consistent with the thermostat. Produces hot water not consistent with the thermostat. Okay, so what do we do about the temperatures? We have that water heater set to 150 on the thermostat. Forget the fact it's only producing 116. What if it produces 150 degree water? Well, the code says that that thermostat is not, cannot, should not be the control for the water temperature delivered at the fixtures. Now we'll see the water heaters that really crank it up because the person says, I like hot water. But I guarantee you they're not taking a shower in 150 degree water. So they're mixing the cold water in there. But a lot of times they'll just turn it to hot, let it run, get it hot, step in there. And that's the point that they can have injury. And I worry, and a lot of times when I'm taking temperature readings, I'll sit there and talk to the client, and I'll ask them if it's too hot, whether or not they have a child they like. And if they like the child, I suggest that they turn the water temperature down, especially infants. But the comment I make there is, if they're an infant, I say, oh, then you still like the child, you might want to turn the temperature down a little bit. So what's hot and what's too hot? Well, do you remember the Legionnaire's disease caused by the Legionella bacteria? That situation is what caused some of the changes so that temperatures were raised. And you'll see that hot water in hotels, hot water in public facilities, hot water in those, they keep the water hotter, but they still have to control it at the fixture. If you start at the top, you'll see that bacteria dies instantly if your water is 158 degrees or more. If it's at 140 degrees, it's going to die in 2 minutes. At 122 degrees, anywhere between a little over 2 hours and 3 hours. But that's also only 90% of that bacteria, and it depends on what kind of bacteria. And then anywhere between 118 and 122, you don't grow the bacteria. It doesn't multiply, but it is alive. It's live bacteria. It's just not getting to be a bigger colony of bacteria. And then down at 90 and 108 degrees, bacteria is just going to grow. That is perfect. It loves the warm water, and it just thanks for the bath, and it starts growing. So what temperature do you choose? Well, if you're going to look at that, okay, 158 is great, but we can't live with that, because you get over here and you see this chart, and you see that at 120 degrees, it might take more than 5 minutes to get a scald, but at 155, it'll happen in a seconds. I think that is in a second, but it is immediate that you have a 3rd degree burn there. So you can't live with that. So what temperature do you set? My personal opinion is I keep it at about 125, because that's going to control the bacteria the best it can while not causing me a personal injury. And if there are children that the family still likes, or infants and toddlers, then I suggest they keep it at about 120. Well, what's the right temperature? We got some conflicting code here, but the plumbing code says that the tempered water control should keep everything to 110 degrees. But you get into the shower valves, and it says it needs to be a maximum of 120 degrees. So there's a little bit of disconnect. But remember that the thermostat is not the place where you control that temperature. You've seen the tankless water heaters with the digital display, and they all max out at 120, unless you go to that great research assistant called Google and YouTube, and you look up, and there is a way to pull the cover, change some switches, and you can get a tankless water heater to heat water higher than 120 degrees. You need to be careful about suggesting that, because it can void the warranty. If somebody complains about it, just make sure you tell them that while they can do it, it can void the warranty. Water temperature limiting valve, okay? A water temperature limiting device. How about this? If you're in a shower and it's a single handle, and in fact, any single handle should have a temperature limit stop, and I'm talking about for tubs, not necessarily sinks or lavatory basins. And the reason is you're not climbing into a sink to take a bath, but you're going to be stepping into a tub and stepping into a shower where that high temperature can hurt you. So within that device itself, there is a stop point so it can't get too hot. If you have good hot water delivery at the kitchen, which is where I always measure it, and that's just for my convenience because I set my tool bag down and start pulling things out. And the thermometer is the first one, and I check the water temperature. But then if I go to the bathrooms and I find that the tubs and showers with a single handle isn't as hot as everywhere else, well, the first thing you need to think about is this valve body and the temperature limit stop itself, not necessary delivery of water to the system. Now, one of the things we're required to report as deficient in both the InterNACHI SOP and the TREC SOP is the orientation of the hot and cold. So let's say that we properly have the cold water come in here to the right side, and we properly have the hot water come in here to the left side. And frankly, that's kind of difficult to miss, especially with the color-coded PECs. So let's assume that this is done correctly, but your orientation is hot to cold in a counterclockwise movement. You see this cartridge right here? That cartridge has inlet ports on either side. And if that inlet, or if that cartridge is installed upside down, 180-degree rotation, that in and of itself will cause the misorientation of the hot and cold. I never say anything other than a plumber should do that. And if they really want to say, oh, I can do it, I say, well, you know what? That part costs about $60. The tool to remove it and replace it costs about $30. So you have a $90 investment. Plumber might charge $300 to do all that work. So you got a $90 investment plus the $300 you have to spend to have the plumber come in and fix it because you screwed it up. There's a lot of grommets, there's a lot of bushings, there's a lot of rubber washers. You damage those and you're going to have a problem. I have replaced that myself without a plumber being involved, but I am never ever going to suggest that a client would be able to do that. All right, so here we have a single body valve manifold and we're controlling the temperature. So what do we do if we're using multiple handles? So this is often what you'll see on the underside of a sink. Now I have about 15 pictures of plumbing design and how these things are laid out that I often use in the longer course. But I'm just going to show you this, and you can look this up. Watts is very popular, and the other one is Leonard. So you can look up the temperature limiting valves, thermostatic mixing valves, and you'll see these diagrams. So remember that this is controlling the fixture. So if we have in a shower that single body valve, but what about the tub? The tub typically has two handles. When there is a dedicated shower, dedicated tub, you might often have a combination tub shower that has the single body. But in a dedicated shower and a standalone tub, you're generally going to have two valves. At that point, there's nothing to control it between the water heater and that fixture. So this device is installed typically underneath the master, one of the master lavatories. And it looks like a real nightmare of plumbing because what happens is you branch off the cold, colds come through, the hot comes through, and it sends it back as mixed and it kind of recirculates. You can adjust the temperature, and that is what sometimes some homeowner will go and say, what is that? And they'll start turning things. So I make a point to show it to the client. I make a point to explain what it is to the client. I make a point to caution the client so that they don't get in there and start screwing things up and then have to call a plumber when it's no more than turning a valve, if you understand what's going on. I personally think that my reports are better when I explain to a client the oddball things that they see and don't understand. Nothing wrong with it. So you can certainly ignore it, not talk about it, but I think your client is a little better served if you explain it. Brenda, are there questions?
Yeah, unfortunately, Clay, you got me this time, buddy.
Dang it.
I know. Hey, yeah, I do have a couple of questions popped up here. Let me get back over. It says, if the BTU determines it to be a boiler rather than a 9-gallon a minute or larger tankless water heater, a boiler. I'm not sure I understand the question. So
Well,
BTU determines it to be a boiler, then is a 9-gallon a minute or larger tankless water heater also a boiler?
no. But if you want me to prove it right now, I can't. But it's, let me get back. 120 gallons, 100 PSI, 210, 200,000 BTU. None of those apply to a tankless that I've ever seen.
Okay, let's go to the next question.
Okay.
Is a parallel multiple water heaters configurations require individual isolation valves?
Yes, because there's a requirement for the supply water to be cut off so that you can isolate it. If you're going to remove the second one, the downstream of the first one, you still want to be able to cut that water off. Otherwise, you have the possibility of, under pressure, all the water in the first tank going over to the second.
Okay, let me see if there's anything else here. No, I think that's pretty much it right now, Clay.
Okay, so we continue on with performance. What if you have an odor, or you have discolored water, or you have popping noises? Well, the odor and the discolored water, we'll start with the odor. Sometimes it just smells like shrimp. It smells awful. It'll run you out of the house. If it's that bad, it's very likely to be the anode rod. We'll talk about that next. If it is less, and maybe the house has been vacant, it could just be a bacterial growth in the water. And in the case of the anode rod, the odor won't get better when you run it. In the case of the bacteria in perhaps a unoccupied house, then the running it is likely to get rid of the odor. You'll have that odor when the house is vacant and they turn the temperature down to warm rather than a hot temperature, and it bacteria grows and it stays there till you've gotten rid of that and refreshed it with hot water. Run into that with vacant houses quite a bit. Discolored water, that can come from the failed or failing anode, and it can come from the bacteria, and it can come from water pipes, and it can come from a lot of different places. More often than not, you're going to see discolored water from the hot water side, especially in homes with the old galvanized. And the popping, that's when all of the mineral deposits that fall to the bottom of the tank or accumulate in the bottom of the tank start exploding from the heat, and that pop is the exploding mineral deposits. All right, so we have the anode rod. Rather than the water heater tank corrode, they have this device inside the tank, and it will corrode to protect the tank. And once these corrode, not only does it start eating the tank, but that's when you get those odors that occur. It all comes down to the flow of electrons, and the anode rod is going to self-sacrifice to preserve the tank. Now, there are those of you that know more about planes and more about boats than I do, but those systems, the motor systems, also have anodes, and they have ways to protect against that same current that is created by the operation of the motor. It can be replaced. If you don't replace it, it will corrode the tank and it will cause the odor. Many people don't flush a water heater, and you really should. And that includes the tankless water heaters. You see all those extra ports on the tankless water heater? That you recirculate the water through the coils and it comes back and it just flushes it. And the manufacturers of those products require that it be flushed several times a year. I don't know of any homeowner that has ever done that, but then they start having performance problems because of the mineral deposits that build up inside the exchanger. Here's the sediment that we talked about. It all settles to the bottom. Here you have the cold water is delivering the new water in as close to the bottom of the tank as can, so that the cold water's down here, the hot water rises, and the hot water pickup tube is near the top. Mineral deposits, I don't know what that is. Oh, I'm sorry, that's the heating element. Right there's the heating element. And while you look at this, I want you to keep in mind this. Now, we talk about 18 inches and will in a little while, but you'll see that this is not at the bottom of the tank. So we have 18-inch stands just because it's easier to say it's 18 inches than to go in here and identify the actual height of that thermostat. And you'll see that this heating element itself is in pretty bad shape. Now, I used to think that the tank was concave and would look like a wok bowl. This tank would imply that same thing, but those tanks that I've seen disassembled now is an inversed wok bowl. So that is the area that is heated, and then all the water on top of it is what, that's what is heated by the flames or the element. And then the water, hot water rises. And that would have made more sense if this was a gas-fueled water heater. That's when you'd have seen it convex. Heating element, it doesn't matter, it's all down there. We are required to report leaking or corroded fittings or tanks, damaged or missing components. You know, I've kept all the pictures that I've had or taken since I started inspecting. And it's just not hard at all to go and find pictures of corrosion and damaged water heaters. As I was doing this, I didn't even have to go back and hunt for some, because every day you turn around, there's another one. Producing hot water? Well, yeah, produced it right here. It's leaking out hot. This is not water, that's the tank failure though, but you obviously have problems with every single one of these. Now these, you've probably seen this many times. This is where the water comes up and there's a fitting up here and it's dripping. And you can see right there where it's hitting, and then the water accumulates and it corrodes. Over here, this is water was running down this flue pipe. These pipes are rolled and the seam is crimped, but a lot of times what you'll see is they don't ever seal at that crimp, or they don't seal at the collar, the storm collar above the roof bonnet. and water just runs down there and drips off this draft diverter and causes all sorts of problems. This can also be poor drafting, because then you get all this humidity out here and it just causes all that corrosion. And then this looks like a failure because that's not a dielectric. And this point right here is the anode. That's the anode that is replaceable if you get that odor or if you get the other problems. But it can be fixed, right? I think we all see problems where the homeowner comes in and tries something. This did not do much good. You still have the corrosion. It may have encapsulated it, so it may not corrode as fast. The problem is by the time they've done that, it's already corroded. And this is what you deal with. No dielectrics, which we'll touch on here in a second. And you see these little spots that look like it might be wet right now. So the first thing you do is reach over there and scrub it, right? Just to see how bad the leak is. That was sarcasm. You do not touch that. You don't break a little piece of the rust off to see. You don't do anything other than report that as deficient, because that can start leaking badly at any point. Leave it alone. Leave it alone. You can see the water actively dripping right there. And that's the kind of thing that falls down and causes you a problem with your the corrosion on the top of the tank. It is no problem to track down these. You can see that it leaked and you had all the mineral deposits accumulate, the salts in the water, and you have the corrosion over here, and it's just leading to everywhere. You have the coupling there at the valve body. They're everywhere. They're everywhere. They're everywhere. And it all comes down to the lack of dielectric couplings, dielectric nipples, dielectric unions. So you have what looks like copper and what looks like brass and looks like a galvanized pipe and it looks like a galvanized pipe. And you see that little piece right there? That's probably intended to keep this, and that would be a fitting to protect against that, but obviously it didn't. So here's your dielectrics. Now you can also see the corrosion from the electrolysis process if you have these, because all it takes is for somebody not to install it correctly. This is the sleeve for going brass. Same thing. You'll see that little dimple in the coupling. That's one way to tell that a dielectric. And you'll see that this is an insulator where this one is a heat trap. And I'll sit here and tell you that I have only learned about heat traps recently. Some manufacturers require that. And you'll see that they're very similar, and it's just the difference of the components within it. But if they both have the dimple, so if you don't have a dimple, then you're going to have to worry about it being just a straight piece of galvanized pipe. And that's when you're more often going to see the problem. Well, here's the answer to your shutoff valve. You have a shutoff valve on the cold water side. That's both of them. Yes, you don't know whether this is set up as in fact, this is electric, this is gas, but even if they're in series or parallel, they each have to have their own valve. We're required to report the absence of a drain pan if the system doesn't terminate over waste receptor or to the exterior of the building, etc. The one on the left is designed for tankless water heaters. And you'll typically see that when it's installed in an attic space. If it's installed in a garage, because it's mounted on the wall, if it leaks, then theoretically the water is just going to drop to the garage floor. Then the manufacturer isn't requiring a safety pan, and I've never seen a safety pan. I would imagine some authority having jurisdiction may require it, but in my opinion, if it's in the garage hanging on the wall, it doesn't need it. But what about water heaters in the garage that are not tankless? Well, because of the requirement that they're 18 inches off the ground, many times you see those sitting in a niche. And if the water heater is sitting on top of that niche with no pan, the water heater hits the platform and it can go and cause damage to all sorts of components. So if you have a tank water heater, unless it is on a metal stand, not possible, where it's not possible for that water to reach the walls, that's the only case it doesn't need a pan. Otherwise, it's got to have a pan. And that pan has to be 2 inches, and it has to have at least a 3/4 inch drain line from the pan. And the pan has to drain to someplace that's safe. Now in an attic, you're going to see on a tank water heater, or you should, always have a pan. If it's in the garage, the drain line from that pan can simply drop to the floor. If it's in an attic, then it has to go someplace that's quote unquote safe, and it won't cause damage to the property itself. Question before I go into the next section?
Yes, sir. Let's see if we can get you to answer some of these questions. What should the buyer do when the temperature setting and temperature produced are so different?
The thermostat setting is different from the water temperature provided. I would say that that water heater has a problem, even though it's functional, it's not functioning very well. And the disparity between the two makes me think that there's a problem that will not be solved without either replacing it or a plumber coming in and looking at it. And if you wait so long to flush a tank that you're having that disparity between the two temperatures, that water heater's at the end of its life. So anytime I have a disparity like that, I say it's near or at the end of its life, and a plumber should, during the option period, the plumber should inspect it and repair, which I don't see happening, or replace it. But I do consider that a deficiency.
Do you recommend vinegar to help flush a water heater?
I recommend that you follow the manufacturer's installation instructions and service instructions and maintenance instructions, and they don't say vinegar.
Okay. Another question that came in is, when two water heaters are connected in series, home warranty considers the second one a storage unit and not a water heater. Home warranty would not replace the storage unit when it went out, even though it is a water heater. Would a shutoff valve between the two water heaters bypass home warranty requirements?
Home warranty company is in the business of taking your money and not fixing anything, or fixing it the cheapest possible way. So frankly, it never occurred to me to read a home warranty to see about that. I'm stunned to hear anybody's ever done that. I doubt it's on purpose. Maybe they came across it. Fantastic. I've never heard of it. I don't think I'll mention that to my clients, because I don't get into the practice of mentioning home warranties. And certainly not recommending home warranties.
Okay.
I'm going to have to think about that. I would, know the separate shutoff valve.
Okay.
It's a system. I don't know a way around it.
Well, I have another question for you. I have a question about waterlogged expansion tanks. We were told recently by a plumber that it is an item we should be writing up, but we could not give a reason why that it was an issue. Is this an issue we should be concerned with?
Waterlogged expansion tanks. Did I get that right?
Yes.
I'm going to have to tell you again, never heard of it. The only time we're required to report as deficient a lack of an expansion tank is if the water pressure is over 80 psi delivered to the house. I see that so infrequently that's not an issue. I see the occasional expansion tank, but I've never heard the terminology waterlogged. So I will write that down and find out.
Okay, thank you. Another question, why are the safety pans equipped with a PVC fitting when PVC is not approved for a water heater safety pan drain line?
PVC is not approved for a temperature discharge line, but I believe, I'm not going to swear to it, but I believe it's acceptable for the pan, but just the pan. And since it's raised as a question, I'll look it up.
Boy, they're getting you this afternoon. They're with it, Clay.
Ask me a question about roofing.
that was from this morning. Okay.
Oh,
Can the TPR discharge pipe finish over the water heater pan?
no. Well, it depends which code you're following. If it goes to the pan, I tell them that while it depends which code you're following, I consider it wrong because the manufacturer requires that you test the valve every year, the relief valve. And if it goes to the pan fills up with water. Now you've got the water heater sitting in the pan with no way to get it out because that pan drain right there, there's a 1/2 inch to 3/4 inch difference between the lip and the bottom of the pan. And I'm not going to put 3/4 inch of water in that pan and have the water heater sit in till it evaporates. It will also keep somebody from testing the valve, assuming they ever test the valve. So I consider it deficient and report it as deficient.
Okay. What about terminating the TNP into the safety pan? Will the safety pan drain line provide proper drainage for a TNP valve?
That's the same. That's basically the same.
Same, okay. And how many years should you expect before needing to change out the anode rod?
Anode?
Anode.
You should be able to get the lifetime of the water heater out of it, which is typically 7 years by the warranty provided by the manufacturer. Some are 10 years. But if you look at the average life of a water heater, and this is the same average life from the InterNACHI's life expectancy chart, gas water heater has 12 to 13 years. Electric water heater has 11 to 12 years. So you shouldn't have a problem with the anode unless you have perhaps some other issue causing more of the electric current, or you have a bigger water problem, etc. I have never in my life had to replace an anode except in a travel trailer.
Okay. And I was
Oh,
going
and back up. If you were to have the TNP valve discharge into that safety pan, if it's a full discharge, there's no way it can drain that pan fast enough so that valve drain would fill that pan up before it could possibly drain out that 3/4 inch line. And usually it's 1 inch, but still it's not going to drain.
Okay, we got you. You can go ahead, Clay. We'll wait for more questions.
We're required to report the lack of protection from physical damage. So where's the physical damage come from? Well, one of the most common locations is the garage. The water heater must be protected from damage, and in the garage, this is going to be caused by vehicles. So what's the simplest way to protect the water heater from damage? Well, you don't put it in the garage, or you don't put it where the car can hit it. That's perfectly good installation, right? I wouldn't walk under it, but car's not going to hit it. Truck will, but a car's not. Now you'll also look where this one is, right in the middle of that drive, but they have put enough junk in there that I think they feel confident they're not going to run into that. So if it's not in the path of the water heater, what can you do? Well, install a physical barrier. But the problem is, what counts as a physical barrier? For the most part, I think that what we see are framed niches or an enclosure, and certainly that's in the new construction. In the old construction, you might have that water heater right in the middle, like the picture you just saw, over on the side where part of it is over in that part where theoretically the car's bumper won't hit, and part of it would be right in front of the bumper. And now they're in that little enclosure, and I would think that a car is going to take that out very, very easily. So that's not much protection. But how do you handle it with the client when you tell them that that's not got any protection? And that means that they're sitting there thinking, well, they've got to have that fixed. So I tell my client, that doesn't look like adequate protection. Neither does a curb stop add adequate protection. So we're kind of looking at post, but does that add any protection? So how do we figure out what kind of protection is adequate per code? Well, let's just start at the IRC Chapter 28, water heaters. It says go to Chapter 20, boilers and water heaters, which says go to Chapter 28, water heaters, which says go to 24, fuel gas, which says go to the manufacturer's installation instructions, which says you should go back to the code. So the IRC offers absolutely no help on what is adequate protection. Let's go to the plumbing code. Well, the plumbing code says go to the International Mechanical Code, which says go to the manufacturer's installation instructions, which says go back to the code. That didn't do us much good either. Well, the fuel gas code says it should be by an approved means. Okay. Or the manufacturer's installation instructions, which takes you back to the code. An approved mean takes you back to a code. And InterNACHI standards takes you back to the code. All right, so we still don't have any answer. But look at this, the International Fire Code does say something about guard posts, and they have to comply with all of the following. Steel, not less than 4 inches in diameter and concrete filled. Not more than 4 feet between posts. Not less than 3 foot deep with a concrete footing. Set with the top of the post, not less than 3 feet above the ground, and not less than 3 feet from the protected object. Well, I told you before, it doesn't take much to find a picture of some of this stuff, but I just never came across a post. Well, this was Monday, just in time to put it in here. Is this an acceptable post? And I'm waiting, and the answer is no, because that's just bolted down to the concrete. Remember, it has to be 3 foot deep, concrete filled, and it has to have a footing, and that just doesn't do it. So the first time I see a post, and it's just not adequate. So you have all these posts that might be out there, but this is the only one that counts, which basically means that I have never seen a guard post that meets the criteria to protect the water heater. So if it's in the garage, you don't have a protected water heater. And that's just the way I treat it. But I do mention it. I don't want somebody to come back and say, well, you said. We're required to report when the burner ignition device or heating element, switches or thermostats aren't at least 18 inches above the lowest garage floor elevation. Now that means that if you have a curb stop and the curb is elevated to maybe another 3 inches, then you're not talking about 18 inches, you're talking about 18 plus 3 inches, 21 inches from the lowest garage floor elevation, not counting the slope towards the front. I'm not worried about that. But remember that heating element and the burner are not quite, are at least 3 inches from the bottom of the unit. So 18 plus 3, you're at 21 inches. So I don't get really worried about that. If it's 18 inches, you're covered. Unless the unit is listed for garage floor installation. Well, beginning 2006, I believe, water heaters had to be designed and listed as flammable vapor ignition resistance, and abbreviated FVIR, water heaters. And basically what that does is it encapsulates the burner and the heating element so that it is not open for ignition. But there are still some authorities that require it to be 18 inches off the floor regardless of whether it's new or not. I don't know whether you have, seen where they took the front panel off, and that would be this section here, if you can see it with my mouse, that section. They have taken it off so that they could use a match to light the pilot. Yeah. If I see one that's been disassembled, I report it as deficient. It's got problems, because I'm not going to guarantee they'll ever get it back together. But if you have one disassembled in the garage and it's not 18 inches off the floor, then it doesn't matter if it was initially rated FVIR, it's no longer. So that's why some still are 18 inches off the floor. And in fact, in new construction, everything is 18 inches off the floor. That way nobody can challenge it. You're required to report the absence of an opening that would allow access to the equipment. I've seen water heaters that were installed and then they built shelving and they put the shelving against it, and there's no way that you have of lighting it without removing the shelving. You don't have any way of looking at the burner. You don't have any way of servicing it or playing with the thermostat. Adjusting the thermostat. So obviously, if you have lack of access, you've got a problem. A lack of a passageway and service platform, that's no different than the HVAC equipment. If there's equipment in the attic, you've got to be able to get to it. You have to have the 22-inch passageway, just like the AC. You have to have a 30-inch high clearance for service. You have to have 20 foot, no more than 20 foot from the access to the attic. And when I find a passageway that's got ductwork and PEX piping and even low voltage electrical and high voltage electrical across it, to me that is not a clear passageway. You try to get that water heater out, or you try to service it or get to it without stumbling over that, damaging something, crushing an electrical cord. I've had agents say to me, well, the client was noticing that you seem to really hate pull down stairways and attics. Yeah, I do. If it's been obstructed, that's dangerous. It's dangerous to me, it's dangerous to a technician, it's dangerous to the client, because who's supposed to test that relief valve? The client. I'm very particular about reporting safety and access to attic spaces. I don't know, many of you may have been on Jason's call this morning with InterNACHI, but you see that you still have to have the level working space. You have to have a switch located at the opening of the passageway. And again, I'm picky. I don't like when they take 2x4s and they'll make a platform of 2x4s with about a 2 or 3 inch space between each of them. What on earth are they trying to save? How much money are they trying to save when they've got scrap lumber everywhere? So if it's not safe to me with my attitude towards it, it's definitely not safe to anybody else. And this doesn't really have anything to do with, well, I guess it does, because you're supposed to have 12-inch clearance between the top of the water heater and the roof deck. But you'll see that whomever installed that said, well, I need just a little bit more room, so I'll just cut here into these rafters. Brenda, I see that we've got about 27 questions, so is there, you want to stop and ask some of those?
Yeah, let's do. My name's not Brenda, but I'll gladly help you.
Okay.
All right, I have a question. Says, should we write as deficient an abandoned water heater tank in the attic that's disconnected from the gas and water?
I don't write it as deficient. I write it as information. You've got abandoned equipment in the attic. Now, if it's abandoned where it's going to cause me an access problem, yes. But I tell my client, here's what I see, and you need to have them remove it. It's just one more piece of junk they've left behind. Now, why is it left there? I don't know if you know this about home warranties, but there's usually about 3 levels, and one of them will fix the appliance, and if it comes and has to be replaced, they will simply replace it without bringing it up to code or removing the old appliance. And this applies to water heaters and to HVAC systems. So if you have one abandoned in the attic, very likely it was replaced by a warranty. What else?
Okay. Question says, are gas drip legs required?
Okay, I'm just going to be smart aleck here and say that in this part of Texas, no. But that's because you said drip leg. A sediment trap is required. Drip legs catching water, we don't have wet gas, we don't need drip legs. We do have sediment in the gas lines from the pipes and the fittings and the couplings, and you're required to have a sediment trap.
Okay, and can the sediment trap gas line be connected in multiple ways?
Say that again.
Can a gas line be connected on the sediment trap in multiple ways?
The gas has to change direction, and it has to be so that the sediment falls. So there's only one real way to do it, and that's have the gas come in from vertically, and the sediment would fall into the leg, and the gas would be forced to turn, and it would be impossible to carry the sediment at that right angle.
Okay. Says another question, different one, says, when is a sediment trap expected to be cleaned?
I don't know of any requirement that it be cleaned.
No, I never seen anybody to clean them anyway.
Yeah.
In our area, sometimes in multiple family structures, we have electrical water heaters installed in the return air located under HVAC units. What are your thoughts about this?
Well, the electric unit doesn't produce any off-gassing, so I don't know that it would, I don't know that there's any code deficiency unless it is access. Now, I've reported those many times because of limited access, but not because of just its location with regard to the HVAC.
Okay. Another comment said, can you please post the image of the IFC code on post back up on the screen?
You talking about that flow chart?
I think he's talking about the post in front of the water heaters in the garage.
Okay. My understanding is all of, does he want me, does it read like he wants me to show it now?
Yeah,
There?
yeah. I think they just wanted to see it.
Okay.
I had a couple of them doing that same thing.
Okay. Well, these presentations will be made available to you by InterNACHI. So you should have access to it.
Okay, got another important question that you asked to be asked. Mr. Robert Rexer said, what about gutters discharging on the roof surface?
Excellent, Robert. Yes, that's wrong. Thank you.
There's your roof question. Okay, let's see. Most pans have a 1-inch drain line. You stated must be at least 3/4 inch. If the pan has a 1 inch, would it be deficient if the 1 inch is reduced to 3/4?
Not deficient by code. Stupid, but not deficient by code. Unless the questioner is the one who actually did that, in which case it's not stupid.
All right. One says, as a student, I was taught that inspecting a tankless water heater consists of does not produce hot water. Do you perform any further inspection procedures for tankless water heaters?
I don't do anything else on a tank water heater. If it doesn't produce hot water, and it's got power, if it's got the energy source, I'm done. I've reported the deficiency. It's up to somebody else to do the inspection. Now you do still have to test the temperature, the relief valve.
Okay. That's all the questions that's posted right now.
Speaking of which, we're required to report the absence of or deficiencies in that relief valve. The code says that you can either have a pressure relief valve and a temperature relief valve, or a combination pressure and temperature relief valve. So I've heard them called T and P valves and relief valves and all the other. I use relief valve. That way I don't get caught up into anything. You can read that label that's there and see exactly what it is, but pretty much any of them that you see that are the standard configuration are a temperature and a pressure relief valve. So what are some deficiencies that we would see? You know what? You're supposed to test the valve, and if that handle comes off, to me it's deficient. I can't test the valve. I'm not getting pliers, I'm not getting tools, I'm not doing anything else other than say, that's broke. We have the missing pipe. We have a missing pipe, but look over here in the bottom right, do you see the buildup of minerals? That one's been leaking. And look over here, we're going to ignore the fact that we've got the leak from the coupling, but that has no valve in it. I'm sorry, no drain line as well. And what about this? Well, you know, homeowners always going to try and do something that they think is innovative. But what they have done is create a situation here. This is wrong, but that's not the real problem. The real problem is this runs uphill. And the problem that causes is this can be leaking slowly, and it can take a long time to get up this high before it finally runs to the outside where you can see it. And for the entire time it takes that to accumulate, you have a dangerous water heater you're just not aware of yet. And that's assuming that this one's not capped off someplace. And the only reason they could have that there is if they open this valve. Well, okay, that means somebody's testing that valve at least, but this is just a configuration that I would say it's deficient regardless, and encourage them to do something better than they've done. And then over here, this is a replacement, and they just got it that close, but they didn't have a coupling with them, so they didn't worry about it anymore. So how far from the ground can that discharge go? I'm waiting, I'm waiting, I'm waiting. 6 inches. Oops. I will tell you that this was quite a surprise to the termite inspector when I was testing that. He's the one who came in and told me that it was a problem. Now, I will also say to you that that means I screwed up, because I should have made sure I knew where it terminated before I tested it. And it was not such a big deal here, but I have had cases where it went into the wall. Now, I was lucky enough to have identified, I was skilled enough, thank you. I was skilled enough to have identified the fact that I couldn't tell where it was draining to. Contacted the seller, who had a little bit of repairs going on, and there was a contractor on site. And I was able to test the valve and see that it ran into the wall, and the seller was okay and had me tell the contractor to fix it. Now that just worked out. So I don't any longer test that valve unless I can locate the drain line. And I think that would be a cautionary tale for everyone. I've also had relief valves that when I tested it, the drain lines came apart because they weren't glued together. We'll talk about that in just a second. And this is wrong. Now, it's not as dangerous as that one, but it's wrong. That water is supposed to drain downwards. Okay, what is the difference between the valve on the left and the valve on the right? Anybody? 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 Well, let me tell you. The valve on the left, when I opened it, water came out. The valve on the right, when I opened it, no water came out. This was the same house, 2 units, zoned, located on either side of the house. No evidence, or my belief is nobody ever tested it. I can't prove it, of course. But you have a valve that doesn't work. Well, you're not required to operate the valve if, in your reasonable judgment, it can cause damage to the persons or property. Damage to the persons or property. Remember that your job is to identify problems for your client, to identify deficiencies for your client. If you choose not to test the valve, then you have chosen not to look at some component. Now, you might say it could cause damage from what? If you don't know where the drain line is, it could cause damage to the property. If it's too high, it can cause damage to you. If it's in a garage and it terminates at the floor and they've got a lot of paper products or other products there that are going to get wet, that can cause damage. So there are times you certainly cannot test it. But let's say you do test one and identify a problem. You have done your job. Now, yeah, you're going to have to cope with somebody complaining about how you screwed up and you damaged their property, and they're going to have to fix it. But remember, you've done your job, and it's a whole lot better to deal with it on that end than to have the client, whom you have a contract with, to provide workmanlike, a proper inspection, and you have not done that. All right, so why would you not? Well, let me add this one. Relief valve and safety pan share a drain line and use a T-fitting. You cannot do that. If there is a T-fitting, I will not test it. And the reason is, if you have a T-fitting and those are coupled together, the water can be coming down and the pipe can be blocked, and it comes back into the safety pan. And now you've filled up the safety pan. And if it continues to leak, it can overflow and it can go down through the ceiling. And it could get the clothes in the the primary closet and the shoes there. Not that that ever happened to me. But I will never test a T valve again. Or I'll never test the valve if there's a T line again. And you can identify that a lot of times because there's only a single drain coming out of the house. Remember that your job is to find problems. Yeah, This is real case scenario. This happened just a couple of months ago. So I identified where the drain lines were. Looked reasonable. Yeah, there's stuff in the wall. So I tested the drain line and no water came out. To this day, I don't know where the water actually went to, but it never seemed to come out except here on the ceiling. This is when I tested it, and then about 30 minutes later, I was doing the thermal inspection, and lo and behold, I see this hot water, and I see this heat. It didn't make any sense. So I come back and I see, we still have that. And this is, by the way, is the window. So this is an outside wall. This is turned 180 degrees from the first picture. This is where the source of the water is. So there's your hot, and there's the water cooling off. And I come back a little later, and you can see that the water is spread. So there's no question in my mind but that water heater drain line was causing this water damage, and it's a problem. But I found it, and not my client after they owned the house. All right, so what's the reason that most inspectors don't test it? Might not be able to get the valve to reset. Well, in my opinion, if that valve is safe to test, it won't damage property to the best of your knowledge, because you've still done your job and it damaged the property. I don't think there's any culpability that you would have here. But you can't get it to reset, well, then the valve needs to be replaced. You can do a lot of things to try and get it to reset. Most of those I try is tap it. I wanted to do a real test here, but we're not able to do poles. But I've heard from people that they never test relief valves. But I would imagine that they would test them in brand new construction. So what I do is try to lift that handle, and if the handle's stuck or the handle doesn't spin, I say it's deficient, because it will not work without the use of force, and we're not required to force it to open, because if you have to force it to open, you got a problem. I would encourage you to probably test more valves than you do, but still keep in mind all those caveats about when you shouldn't. If you never test the relief valve, so if you say you don't test them in a home that's 10 years old, and you know that home's 10 years old, then you talk to that client on the phone, you need to be telling them, I'm not going to test that relief valve. That's not a decision that you made when you got there. You just need to be real careful, because this would be a violation of the standards of practice. And what about the drain lines? It says that I think I got okay, here it is. The discharge line must be as short as possible. And some tags say no more than 4 elbows. Well, 4 elbows is almost the minimum. So you come out of the tank, right angle to go down, right angle to go across the attic, right angle to go down the wall, right angle to go out the wall, and right angle to go down. That's 5 elbows. So that doesn't make sense, but as short as possible certainly does make sense. The more distance it is, the more likely you're to have a problem trying to get that water out under high temperature pressure. Valves should be re-inspected, and every 3 years, and a lot of times they say it should be removed and replaced. Well, if I have a 3-year-old water heater, I can guarantee it's never been tested by anybody but maybe a home inspector. So if I see an older valve, I put that information that the manufacturer requires inspection and replacement, and it probably hasn't been done. I recommend that they have a plumber do it. Certainly in the older ones. And let's see, we're not required to verify the effectiveness of the valve and the discharge piping and the drain pipes. Our testing the valve is not verifying the effectiveness. Verifying the effectiveness would be to raise the temperature and the pressure. All we're required to do is say that the pressure relief valve is allowing water to come out and seating. What can we test? You can or can't open the valve. It either does or doesn't, assuming you try. If you do open it, water either comes out or it doesn't. Water causes damage that you can see or it doesn't. That whole concealed damage might take a while before it actually shows up. But again, be careful before you test it. But I still think you should test it.
You've got Brenda again. We kind of team talked this afternoon. Okay, so how do you handle a very angry homeowner who sees that the TNP valve is now leaking and will not close?
Valve needed to be replaced a long time ago. Your job as an inspector, your requirement is to test the valve, and apparently they didn't. So I'm very sorry that you didn't do the maintenance that's required, and obviously I wouldn't say that, but I have had to deal with it, and I've had to say that valve requires maintenance, and the maintenance wasn't done. My job is to identify a problem that is a life safety problem, and I've identified that. That valve is deficient, needs to be replaced.
Okay, and someone wrote, I worry that older systems have sediment buildup and will not close after opening.
If it is an older system, and I just turn that valve a little bit, if it's older, I'm able to say, it wouldn't work without force. Yes, if it's a 10-year plus system, I become hesitant. If it is a 15-year-old system, no way in Hades will I test it. But up to that, I don't think you have much excuse. But at 10 plus, I think I'm comfortable saying it's deficient because it's never been tested. Replace it.
Okay, can PEX be used for TNP piping?
No. It'll handle the temperature, but I don't know if there are limitations in code or the manufacturer. Mostly it's going to be size, but you do have 3/4 inch PEX. I don't know. That's a good question.
Okay, and I'm looking at the time. I know Paul asked some of these, so you may have already answered them. So I just want to make sure I get everyone with questions, get those questions answered. If you have additional questions, please send them in. I think I've asked the questions that were here. Paul asked some of them.
Let's keep going then.
Oh, wait just a minute, Clay. Do you test TPRV if you can't see where it exits?
I do not. That's what I said. You check if you can't see where it terminates. I do not test it. But I also explained the why I didn't test it, what the risks are. And the risk is the valve doesn't work, and the risk is that if it's tested, it's going to damage something. And in that case, they need to identify the termination.
Okay. Thank you very much. We've got about 10 more minutes, Clay.
Blankets. I don't believe the blankets are necessary. The manufacturer can void the warranty if there's a blanket on, especially if it covers the label, covers the access panel, covers the release valve. And I see that many times. Blankets aren't necessary, certainly with the energy codes that's got. And here's a perfect example. Look at everything that's been covered down here. Special considerations, electric units. We have exactly the same thing. How do you evaluate the performance? Well, the only way to really know that is to look at the temperature settings and see if that's commensurate with the temperature reading. You're required to open inspection panels. So there's really no excuse not to open that and look at it. You can also see water leaks in there at times. So if you see water staining, you need to be reporting that. And let's see. Evidence of leaking, the setting, we'll skip that. Condition of conductors, well, we're not talking about the heating elements, but you have a water heater, an electric water heater. The conductors going to it have the same restrictions, requirements as any other electric component. So this is obviously not acceptable. It's required somebody use the PEX, but I still don't know whether it's acceptable. You have no disconnect. The panel's not in the garage, the panel's not accessible, visible. You got to have a disconnect. Consideration for gas units. Shall not be installed in a room used as a storage closet. Now, we're not talking about just a clothes closet. We're talking about a storage closet where you might put things that are combustible. I know clothes are combustible, but I'm thinking chemicals and utility type stuff. Not a bedroom or bathroom. Remember that we're talking about gas, so it's got combustion air. It's got air exhaust that's going to have the combustion byproducts like carbon monoxide. If it's in a bedroom or bathroom, then it needs to be in a sealed enclosure so all the air comes from the outside. I don't see that anymore, but that is older homes. Yeah, I still see that. Newer homes, absolutely not. Direct vent doesn't have the same requirements because you have both the exhaust and intake there, so you don't need any ventilation. I still would complain if I saw that in a closet that was open to a bedroom. Now, you can put the water heater and AC in an attic space that you get through to the closet. So you, from a bedroom, go into a closet, through a door, into the attic. As long as the ventilation of the attic is proper, you're okay. Specialized equipment. You're not required to have gas or carbon monoxide detection, but you're supposed to identify gas leaks. So how do you do that? Well, you know what? About all you can do is smell it. If I go into a house that I smell gas near the water heater or the furnace, they got a gas problem. If I go into a house and I'm not smelling that, then I don't really feel a need to go and get a carbon monoxide, combustible gas detector or anything else. I can look at proper drafting or evidence of bad drafting to determine that there's a problem and I don't need the carbon monoxide detector. So I have those tools, but I don't bring those tools out unless I've already identified the probability of a problem. And I don't think I'm doing my client any disservice by doing that. You're supposed to look at flame impingement and the condition of that. All this talks about age. All of this is a problem. That scorching there is probably a draft problem. And over here is a case where somebody pulled that out, and you can see the screw up there. They had pulled this off. I don't see a matchstick around there, but this is the case. Absence of a gas shutoff valve within 6 feet. Gas appliance connector that's more than 6 feet. Gas appliance connectors where you have 2 connectors tied end to end, concatenated. So you only need one connector, can have one connector. If you have multiple connectors put together that way, there's too much movement there, too much possible movement that can cause a problem. And connectors concealed within or extended through walls, etc. Don't usually have a problem with this 5th bullet, except if it's maybe an appliance that's been relocated and they just drag the connector through the wall. I have seen it, just not very often. Deficiencies in combustion air. All right, that's a case of we don't have the air coming in. If they have it in a sealed closet and it's not a direct vent, they don't have air coming in low within 12 inches and high within 12 inches, or vents that come in from the attic. Missing shutoff valves or the type of shutoff valves. I report it when it's the obsolete valve. It needs to be the ball valve. Gas connector, appliance materials, vent pipe draft hood, all of those things, and we just come over here in the interest of time. So that's a potential for a problem, right? Now notice the strapping. These are supposed to be strapped. And when they're not strapped and they're like this, I can almost guarantee you that they've just had a re-roof. It was just recently roofed. And since it wasn't strapped, that vent moved and all of a sudden you have contact. Well, this one, that foam's not rated for direct contact and it's only barely got a slope. But look over here. Now, when I did that inspection for a client, the client was living in the house. She had not bought it yet. She wasn't renting. She was just living in the house. And at this point in time, I didn't understand why she was living there. So I go up in the attic and I see this and I come down and said, ma'am, I'm sorry, you have a problem that needs to be addressed immediately. All of this is happening. Scorching, contact. This rafter was workmanship, but this is a life safety hazard. The poor woman nearly fainted. The reason she was in the house is because her house had burned down for this very reason. And the seller and agent allowed her to move in while she was buying it. So she not only had a house burned down because of it, she was moving into a house that had exactly that same problem. One last thing on this picture, look down at the bottom and you'll see that this is installed incorrectly. This bottom portion is on the outside, so combustion gases can come on the outside. This obviously should have been on the inside, but I don't think they knew what they were doing to begin with. And it's pretty simple to install a gas vent. You just need to use the right kind of duct tape. Now the problem here is they were mixing brands of coffee. They should have all used the same kind of can. Other deficiencies, you have improper installation, you don't have the clearance. I'm going to call that lack of clearance. This is disconnected. This is disconnected. This is disconnected. This is an articulating elbow that broke. That's not fixable. That's got to be replaced. That it's got its own problems. Here is a drip leg, not a sediment trap. That is a drip leg. If that were turned, if that T were turned and this came down vertically and that's this way, then the gas would turn and that would be a sediment trap. This is an obsolete valve. Obviously, this is copper pipe used as a gas connector. The gas connector has to be flexible. So you use copper, but not as the gas connector. References, I'm not going to read those, but there are plenty of references with regard to the water heater. And you see that tracking through those can get to be interesting. Questions?